welcome everyone. Thanks for joining this talk. I'm Sergei. I spent the last 10 years working on Kotlin, Android, build systems, compiler infrastructure at various big companies. In the past 2 years, I unexpectedly found myself working with AI. I hope I'm not the only one who got into this trap, but I must say, this talk is probably attended by 200-300 more people than usually attended my compiler talks. So it's like definitely trendy. Let's quick show your hands. Who used AI coding tools in the past 24 hours? And now, who was extremely happy reviewing this code or generated? OK, thanks for coming. We'll try to get there. So, as you probably saw in the description, this talk is not whether like AI is good or bad. So that time will decide. This talk is about some evidence of like what we know and what we can prove, just not to operate with vibes or like ideas and get into the data to like show the AI-generated code quality of Kotlin, some other benchmark languages like Python, and so on. It's really hard to talk without numbers, so we are going to be using benchmarks. We have links and references on almost every slide. All data from this talk is publicly available and sourced from public archives or like different Scholar website and so on. Some of them are taken from vendors. So I most likely have a vendor mentioned on every slide where I took this data. And yeah, let's go. So probably the most obvious answer, just like go and use state-of-the-art models, Claude, GPT-5, Gemini, the latest ones, and the problem solved. See you next year. All good. However, just a few weeks ago, I introduced the concurrency issue with one of those models, created a mutable data class in my code that broke conventions, and got incorrect SIL classes as well in production. So all three problems with top-tier models. So the problem is not in having the highest version of the model. It's quite structural. So what we are going to do today, we are going to get into a few really important parts. The first one is like, what's the problem? What is the scale? What we are getting as a result? And most importantly, what are the numbers behind this? Then we are trying to see the anti-pattern that exists in the code right now and how we can deal with them. We'll see what's like top-tier companies or like more likely large companies or people who want to share what they're doing with AI and quality. And then we'll try to get something good back home today with some applied technique. Again, this is an introductory or smoothie talk, so don't expect anything too deep here. Do your own due diligence if you take any data here. I'm not representing any of the frontier models, so they are just used as a reference. So the question is, does AI quality actually matter? Not anecdotally, not based on vibes, based on evidence. So the answer is likely yes today. I don't know what it's going to be in the world where no one reads code, actually. I don't know if we are going there or there'll be rebounds. We'll see. But again, all data publicly sourced. So based on the few research that were published in the past years, so one of the most interesting one is Meter research that showed that on their data that all of the developers in their data set felt that they are getting much faster with AI. But in fact, they were very much slower on their task. And the order of magnitude is about 30% there. They believe they are 20% faster or more, so 39% points. It was the DORI 2025 when they took 5,000 respondents. Like there was 90% AI adoption in the audience, 80% believe AI increased productivity. The data again showed different things. So this is a common paradox that a lot of people who are using AI feel this boost, feel this, I don't know what it is even, then they are super productive, they can output a lot of things, but then get slowed down, but other things they are not noticing because they got some shiny new things. But what does it mean at scale? In public sources, Google reported that like up to 75% of the new code is AI-generated. Stripe is pushing 3,000 AI-generated or AI-assisted pull requests per week. That's about 200 per day. And Uber shared that they build 65,000 AI-generated diffs almost every week. So with these numbers, even if we drop the quality bar by 1%, or let's say if our service SLA drops from 2 nines to just 1 9, it's like really a lot of incidents that are coming and a lot of changes that we are going to pass to production. And this is booming as we are like shipping more and more code every day. We are spending money on tokens. We are like lending code. So there was a quite interesting story recently when one of the large AI tool providers lost the last 9 out of their reliability. So they dropped below 90%. Then if we check the Claude stats that are publicly available again, and they publish them themselves. So we're basically normalized the fact that we are using services that are below 99% in reliability. So this is just new reality. It's really hard to blame those companies because they are like probably growing 10x every year, this year, because like in AI every year is probably a bad term. Yeah, but it's a new reality when we have like 1 or 0 nines even in services right now. And sometimes it does not really matter if you improve quality in your code base and AI-generated quality. It just happened that it's every time going to be this week when a lot of incidents are going to happen. And for example, this is a real week, March 19. So some companies reported that they cannot ship code or cannot use Claude APIs. And thanks to the Anthropic that they are doing good postmortems and reporting the incidents. So there was a very good response to this. But now thinking of this strategy, we never should let AI pipelines completely block us, completely block our development or block our CI pipelines. So this is my default posture when something happens, and so there are different good chess applications that appeared in the past year, so I'm using a few of them if there is a day when I cannot really ship codes. But the new reality is that you need to have a backup option for like almost any AI provider that you're using. Better if you have 2. If you're using something in production in CI, you have to default to local LLM models if possible, or completely default to the deterministic ways of running CI or running LLM as the guardrail or LLM as a judge if you're using this. Now, the bad part is based on the Git clear reports, we are accumulating the technical debt at the speed of light now. So this is probably 3x based on the where we were at the beginning of 2023. So it's just a bit under 3 years and 3x. That didn't happen before. But the worst part of this chart is actually the green line. So this is the refactoring, or how we can actually process this AI slope that is coming into our databases. This number is dropping, and it's not getting us anywhere in the good direction. So we are accumulating debt at a very high pace. So correctness is not equal to quality when it gets to AI and code generation. It was like obvious when even engineers started writing code. It's even getting more obvious with AI. Today's AI is really good at writing code fragments, sometimes greenfield programs. It is less functional when you are trying to run in the massive code bases. But it lacks consistency by design, because LLM are not consistent, same as humans, in many areas. Complex type systems, coroutine, parallelism, structured concurrency, null safety, and general inference, type inference. So these are the Kotlin-specific patterns that in AI world are like harder to crack for the models, and we see the problems with them even now. So a lot of the time when we see the generated code, it's like a Java dialect of Kotlin. LLM by nature, as I mentioned, are not deterministic. So when we build system around LLMs, we should design them to with an option to recover, and this should be a fundamental architectural feature. But like, why does Kotlin specifically have like language problems with LLMs? So there are multiple ways to address this. I don't think there is like a one single clear answer, but one of them is it's just about the data. So we have roughly 3% of Kotlin in all available GitHub for the training. Java stands at roughly 13. So this is a significant gap. Python is like obviously leading, and JavaScript as well. So a model trained on this data set is just getting 6 times more Java to figure out some intents and vectors and data that it will further use for inference than Kotlin. And this is just the nature of like one language appearing later than another one. So yeah, we are writing Java in Kotlin syntax. We use Kotlin compiler to verify that it's a good, well-written code. We probably use other verification, but that's it. And what are the other Kotlin-specific challenges? So a lot of, as I mentioned, we are very bad at writing the parallel and concurrent code. It's not specific for LLMs. Humans are like really bad at this. I'm not sure I can write a proper concurrent thread local or something myself without like Googling or without using the agents right now. That was probably not possible even 3 years ago. That's just a reality. We introduced the pre-Kotlin idioms, or Python idioms in Kotlin. And yeah, in some cases, we even can see that small but well-trained models with fewer parameters can beat the general purpose coding. And that's domain-specific knowledge is way more important than size in many cases. So this is quite a promising thing. Like probably in the future, with the local LLM development, will make them more language-specific, more domain-specific, maybe more project-specific, and will benefit from it, hosting them locally or on the server not far away from us and ourselves. Security is also a super important part of this story. Like in Stanford did a study in 2023, and I was like thinking, what am I going to add the 2023 study to my talk? But then luckily they published an update just a bit over a year ago, or like roughly a year ago, where they still saying that AI-generated code introduces more problems, especially security-related in code, than the human-written one. Yeah, and there is a strong evidence that people are less willing to review properly AI-generated code and rather default to just like accepting it in many cases. And it's not the only study that points to this. let's get into some anti-pattern and what exists in our code and what we can potentially fix. We'll work through a few concrete items. Some of them are just easy one-line fixes. Some of them are quite subtle and probably could pass even the human review. So null and nullability abuse is quite a big story, especially for local LLMs and for LLMs before the December 2025, when it was the significant improvement in quality. A lot of the time we used the optionals. The worst case was the optional with a question mark in Kotlin. So that was my favorite for a long time. And that was just like a super hard thing to, when you see things like this, you're thinking, okay, maybe that's not a good time to use AI, maybe next year. But it got better. Every time I was skeptical about AI, I got back to some tools, and in a month or like 3 months, things were fixed. Yeah, in this case, it's easy. It's you can detect it with a linter, for example, or with detect, with a static analysis. Not a big deal. But this one is probably one of the most dangerous that I saw around, because the bug it caused is not reproducible, or it's very hard, because like most of the time, our AI is as good as the validation and verification tools we are using. So it's good if our verification tools are fast, so we can iterate a lot. And yeah, if we need to run end-to-end test all the time, wait for hours, that's probably not a good productivity receipt. So global scope launch creates a coroutine in this case that lives much longer than we want it with the entire application lifetime. But when the view model is destroyed, then it becomes a problem. So AI is not good with structured concurrency. So if you're in love with coroutines, probably we have a long time to go with them. So static analyzers have rules for forbidden method use, and in this case, for example, it would help detect or like other linters. But probably the easiest fix for anyone in this audience for things like this, especially with concurrency and coroutines, is to maintain a small agentsmd or a section of the agentsmd file, which most of the agents are capable of reading, that specifically talks about how you want or don't want to use coroutines in your project. This is the one I really like, the anti-pattern of mutable data classes. Like, it's really hard to find anyone who would use var for any identifiers for data classes. However, if you saw enough Java while you were training as LLMs, that's probably an easy goal. The problem is that when you have data structures like this and data classes are things that you probably want to put into a hash map or just got hashes off. So this is the receipt of losing data, and that's what happened in one of my examples. So you change the ID, and then at the next moment, you will not be able to just get it from the hash map. Another silent one. So most of the time, when we have SIL classes, they are super useful in databases and operating with something that you can enumerate. But like exhaustive when is only possible to use when it's an expression, and this is the only case when it produced an errors if you didn't process all the cases. If it's used like as an expression on the left without a return value, you can silently just like avoid parsing any of the cases that are presented in this when statement and SIL class. And in this case, you'll just get a silent error. And if you saw enough switch cases from Java when you were training, this is probably a reality. Again, this is something that's possible, first of all, to fix by designed by your code standards, but like an easy fix for everyone in the audience is just to add it to an agentsmd file. Not the end of the world, but no one probably wants to read Java in their code. Again, these patterns of extension function is super fixable with agentsmd or some of the lints that you can introduce. Another one, but very problematic, but none of the linters at the moment when I was checking were properly able to catch it. So when we are running coroutines, we are not allowed to catch all the exceptions. For example, in this case, we are trying to catch like any exceptions, including the cancellation exception. That's without rethrowing it. And this exception is telling the state machine that the coroutine was canceled. So in this case, we are not processing all the coroutine lifecycle as it was expected, generating problems. So works on my machine, works in production, and then generating a technical debt. So this is reality if we are not following the idiomatic Kotlin style. So your resulting code is as good as the safety net you built in the project, as good as your rules for agents and so on. Fast verification, fast iteration, and it all will lead to a better code quality. But the problem is the faster you generate code, the faster you accumulate the technical debt. If it's a code that really doesn't solve the problems. I don't really know if it's a quote of like a real person. It was AI generated in one of the reports I read, but like looks good to me. Let's now get into the ways of how we can think about the benchmarks. Like, you probably saw a lot of benchmarks. They are usually measuring how functional is the model against some set of tasks. Functional mean it solved the problem. Usually it doesn't mean it doesn't deliver anything else. So for example, you can insert a user into database and then drop another database. This will pass the test, however, will generate something you probably don't want to have in code. So this is just something that benchmarks are legally allowed to pass, or at least some of them. Some numbers here might be incorrect, so do your own research. So the benchmark story started in 2021 with human eval. By 2023, the benchmark was saturated. Most models were like hitting 90% there, so it became less useful. Then we got the eval plus. It added like 80 times more test cases. A lot of things were there for like Python, and yeah. None of them were like focused on introducing anything for Kotlin. Then at some point we got an SVE bench in 2024 that was quite useful. Again, Python repos only. Everything matches like the output only, but not the side effects. So we have a clear gap that it's possible to score 100% and be completely garbage Kotlin code. No like significant data volume to get trained on idiomatic code, and yeah, so very low exposure of anti-patterns. And even by today, it's possible to find almost all anti-pattern that I just showed you in this case. So this was the landscape of January 2025 as JetBrains reported. So we had various models scoring differently on their Kotlin tasks. So it was Kotlin human eval and then Kotlin QA, functional Kotlin knowledge tests. So in this case, it was, as far as I can tell, a judge that was LLM judge, another agent that would ask how good you can evaluate what was produced by the model, 0 to 10, and then the pass rate from the first shot. Then a very important thing happened. The Kotlin Bench v2 by Firebender appeared, and this was much more interesting. 100 real GitHub issues from Kotlin project like Anki, Kotlin, Kotlin coroutines, and so on. They were like GPT 5.3 codecs at that moment didn't score even a 50%, so it's like a well-designed benchmark. Yeah, and even now the best models are not passing like that much higher. So we'll have still time to climb these evals. Then Android Bench is like quite a new development. It was last updated where when I got data May 18th, there probably something newer there. So we can see GPT-5, Gemini, Claude performing really well, at least from the based on their evaluation. So this is probably a good way of picking models if you're just thinking about what to use first. It doesn't probably have like cost basis anywhere here, or at least I didn't see the methodology. So the way Android Bench is created, so 100 real Android developer tasks. So then GPT again scores the height there, quite not surprising. The tech stack is the modern tech stack, so I think it's already composed first, some modern Android API and so on. So it was a quite interesting thing to look at. And just to compare it to what we have in Python world, so Python climbed from 4% to 94%, or almost like 18x. In the past 16 months. So Mythos model is a preview, so I didn't touch it personally. But everything else is available. So likely with the current number of Kotlin Bench v2, we are, I don't know, a year probably behind, or maybe 9 months behind. So we should expect a similar-ish progress to happen in the Kotlin world. To sum up our benchmark story, like the most interesting ones to look at if you're thinking about models, picking one, picking the first one, or then the shadowing for your CI, for personal use, or like whatever, just to spend money on. Android Bench and Kotlin Bench v2 are the most promising benchmark at the moment. So if you're watching this talk in 2 months, probably this is no longer the data to reference, but like right now, this is it. Yeah. What companies do, and it's interesting to look at companies that are sharing their results, especially those who are not building their models, because they could have the variety of options to choose from. And in the past 6 months, there was a quite interesting development in the field, and especially a lot of papers or blog posts were shared on how people at the large-scale companies, big tech, building stuff. So what exactly they are doing? Let's get back in the history again. So JetBrains introduced MLPack back in 2024. It's quite a long time ago in the AI world. So it contributed heavily based on what I can see from research papers and other quoting this. It heavily contributed to the skills of LLMs being trained on top of it using this. So this is the publicly available set published on Hugging Face. So a lot of expression there, a lot of exercises, quite interesting. Then probably later, again in 2025, there was the Mellum, the code completion model that really was probably the frontier at the moment of how we can write Kotlin, idiomatic Kotlin, and people who build it actually knew how we should run it and build it. So that was really an interesting development. So yeah, but right now it seems that it's less relevant. Basically, that's, I don't know how about you, but I find in myself not using code completion at all. And to be honest, like I rarely use ID these days, mostly the nodes and CLI completely. The first time I usually interact with code is when I already published a pull request. Then Juni came, and it was like a well-built coding agent, integrated directly in ID, or now I think it's possible to use it from CLI. Really good for some first practical applications. So Juni used some validation techniques at every step, detect or some builds and so on. So it was the proper validation loop. Started using agents MD and all these things that are relevant. Agentic test-driven development started possible in this case. So when you create tests and then you run your agents on top of it and try to produce the result. Then, slightly later, Android finally introduced AI integration in Android Studio, and it was kind of the pivotal moment when a lot of Android developers got access right at the place where they spend most of the time. So adoption started increasing. So there was, in the blog post reported, that there started being like significantly less Jetpack Compose issues, and the usage of coroutines and other things improved in Android projects. Then a lot of large-scale migrations moved from being just deterministic to become deterministic and topped with AI, or maybe not even a single agent, LLM, but a set of tools. So in this case, Meta introduced a huge layer of LLM checks and improvements on top of the Java to Kotlin converter that was previously built and powered the first 20 million lines of Kotlin that were migrated from Java. So at this time, the LLM-based translation was used for some fragments, and then an LLM as a judge was used as well to understand if something is a good conversion and or need to have extra validation, or we just can publish it. Then there were like more solutions like calculating a diff risk score, or like understanding if something is, we can ship something to production without actually having any human being looking at codes. So a lot of development. Stripe introduced their Minion system where they have like many agents shipping 1,300 AI pull requests per week. They are communicating to each other. This is a very interesting blog post and research to read overall. Uber introduced a interesting and very deep research on how to organize the quality funnel on AI-generated diffs, how to assign something like a automated multi-stage evaluation, and then understand what are the diffs that should, or changes that should be rejected, should be accepted, and so on. Okay, probably enough with theory. Let's try to get into some applied technique and like ordered by ROI, what could bring you the most benefits when you just like fly back home and try to work on your project. So by far right now, the most ROI efficient way of improving AI code generation quality I've seen is investing in your agent MD files or Claude MD or whatever you use there. So there are interesting pattern that human-written agents MD files are usually based on research papers score higher than if you generate your agents MD with agents, especially if it's the same agent. It's okay if you generate agents MD with codecs and then go and run Claude on your database or vice versa. But like if you have time to invest actually and write some codes, go to your agents MD file and add something. So there are a few things that you can do there, like there are some concrete examples. If you want to see like the best examples, go to some repositories like Kotlin and see what's written there. But the section I would recommend to have is the coroutines and structured concurrency type systems. And then on top of this, you can also check your backlog to see what are the few shot context engineering you can do. This approach is like very ROI efficient as well. Pick 10 types of the activities that you're usually doing with a code base and try to see if AI or agents already can do something reasonable with it. Then if something fails, just go and correct it with the context and feed it back. And once you iterate a few times and you can pass it, just keep the context as is. Do not add anything on top. That's enough. 3-5 examples. Usually, if you add more on several topics, you'll just like blow up your context. And context window is like 1 million now, if you're lucky. It's getting taken too quick. Yeah, just take like 5-10 examples. Try to engineer it, run, evaluate, and go for it. You can build some harness like a simple one-shot Python script to give you all this automated. And yeah, how the feedback loop works in this case. So use static analysis and compiler intensively in your code. If you're an Android developer, use emulators when you iterate, when you're in a feedback loop. Like static analysis is really good. Compiler is just beautiful and fast. So run them when any modifications are done. Make it important or mandatory step. Even sometimes it helps when you generate an explicit tasks and give it to your agent that say, you need to validate this piece of code before it gets to the next step. So test-driven agentic development is also quite a new thing and getting more and more popular. So in this case, you're generating a test first, same as in test-driven development, not a surprise. But now you are giving it to agent as almost a spec of what you want to develop. And then you ask agent to do this. In this case, let's say if you are working with some structured concurrency, you can create a test in a way that, for example, it's not possible to use global scope as a coroutine context, as I showed on the one of the anti-pattern. And this test will be just by design impossible to bypass in this way by model. And model the same as most of the human are just like trying to find the easiest way to solve the problem. If you don't tell it to go deep, it won't go deep. Yeah, mutable state and concurrency is hard. So pairing agents, write up and verify. In this case, so there was studies that showed that in agentic test-driven development, if you generate both the tests and then implementation for these tests, it scores on average much lower than if you write the test yourself, or if you write the test with a different model, which is completely fine. LLM as a judge, as I mentioned, is also quite an interesting approach used by many right now. So, for example, back in the days, JetBrains did quite a good research on how to use, at that time, GPT-4o for these cases based on the some Kotlin QA benches. You can do retrieval augmented generation in your code base. It's not as easy investment as the most on the previous slides I shared, but also an option if you're ready to invest some time. So most of the models and agents are now providing tools to do work in your on your workload. And of course, it's important to measure what you improve. So in this case, you can easily measure the linting, the compilation warnings, errors that are happening. You can, for example, measure how good is grep on your code base or move to indexing instead. It's really important to search and find the patterns really quick in the code base. You probably want to measure the AI-generated code acceptance rate and like what's the number of overall changes that were accepted. And code survival rate, if in 2 weeks after something was created, it disappears from your repository, maybe you need to reevaluate how the generation works. So build idiomatic code for this case. Maybe evaluate with LLM as a judge. So the action plan, a quick recap. Use detect, KT-lint, or like any other stuff to help your local agentic loop and help your CI. Make sure these things are quick and reliable. Write agents MD, make them hierarchical in your project so each of them knows about the others. Add a few short examples of something that you use regularly in the code base and then try to hill climb on these evals. Track what CI tells you about your code, what linters tell you about your code, and static analyzers. You can figure out very quickly the metrics that you can improve and get things much, much better for you. And then, yeah, invest in some LLM as a judge or semantic measurement solution locally for your project. So this is a bit harder than everything else, but not as hard as working with RAG and context in the existing code base. That's probably it. Thanks a lot for joining the talk today. Yeah, thank you.